Okay, here we go with lesson 2.4, rates of change and tangent lines, and the audio is working now. In this lesson, we'll calculate the average rate of change of a function over an interval. We'll find slopes and equations of lines tangent to a curve. We'll find the equation of a line normal to a curve. We'll use and understand these phrases, tangent line, normal line, and rates of change. So, this says to find the average rate of change of this function over the interval from 2 to 3. Does anyone know what the graph of this looks like without using their calculators? Yeah, it's the S curve thing, right? It's going to look a lot like y equals x cubed, except it's going to be shifted up 1. Let's sketch this. Now I'm going to have 2 lines. Okay, so now my computer's really slow. Look, I have an axis now. It's going to go through this point. When x equals 1, the y value will be 2. When x equals 2, the y value will be 9. And when x equals 3, the y value will be 28. It's going to be clear up here somewhere. When x is negative 1, the y value is 0. So we have this nice curve. When it asks for the average rate of change, what it's really asking for is the slope of this line. What line you say? I don't know. I'm afraid that my recorder takes up too much CPU. I'm going to turn off some of these other programs. Sorry for the delay. Still really slow. When you were a kid?
Like, yeah, we're thinking about it. Don't think of it. Yeah. I don't know, it just got really funny right now. I was like, Dan's reaction is always like, I don't know.
All right, so the average rate of change of f of x over the interval from 2 to 3 is the slope of this secant line that goes through the point 2, 9, and 3, 28. The way we find the average rate of change from 2 to 3 is we do f of 3 minus f of 2 divided by 3 minus 2. The change in the function values divided by the change in the x values. So in this case, that's 28 minus 9 over 1. So 19 is the average rate of change of f over that interval. In other words, the slope of that line is 19. Any questions about the average rate of change? So I had this curve. I have a cannon. Suppose I had this cannon and I'm pushing it along this curve. You with me on this? And I stop at this point and fire the cannon. The projectile from the cannon's barrel will go in a straight line wherever the cannon's pointed, right? If I extend that line, it makes this line that I call the tangent line. This is the line tangent to this blue curve at that point. We talk about slopes of lines, but we could also talk about the slope of a curve. This curve has a changing slope. At some places the slope is steep, and at some places the slope is not so steep. Right? Imagine the cannon going along that curve. It's always changing where the cannon's pointed as the cannon follows that curve. And so at any point, if the cannon fired, that path that the projectile takes is the tangent line path. The slope of this tangent line is also the rate of change of the function at that instant. It's the instantaneous rate of change, not the average rate of change over an interval. It's the instantaneous rate of change at that point. Now, in the last example, we took another point down here somewhere, and we found the slope of this line, this secant line, that should have gone through those 2 points. Right? Now the slope of that line, it's pretty close to the slope of the tangent line. Right? I want to find a way to find the slope of the tangent line. We were able to find the slope of the secant line pretty easily. Any ideas how to find the slope of that tangent line? Or, if not that, to get a better approximation for the slope of the tangent line? Noah? Find the slope. Which 2 points, though, should we use? So here we use 2 points, this point and this point, right? And this slope's pretty close to that slope. But if we use a different point, still on this curve, maybe this point and this point. And we find the slope of that line. Let's see if I can get closer to this. That one's almost the same slope. Right? And if this point got even closer to this higher point, my slopes get closer and closer to each other, right? In fact, if I think of this point as 3, and this point as some x value, the slope of the tangent line equals or how about, now I want to say equals, but I'm going to leave a space here. F of x minus f of 3 over x minus 3. but only when x is getting really close to 3, right? And the closer x gets to 3, the closer this value will get to the actual slope. So what should I put here? The limit as x approaches 3. This will give me the slope of the line tangent to the curve at x equals 3. Here's another way to think about it. If we call this distance h, now, I want to make all this somewhere over here. This x value would be three plus h, right? So I could use a point further up on the curve, and as that point gets closer to this point, then the slope between the 2 points is the slope of the tangent line. So the slope of the tangent line, another way to write it is the limit as h goes to 0 of f of x plus h. No, I'm using 3, not x. F of 3 plus h minus f of 3 divided by 3 plus h minus 3 but this 3 plus h minus 3 is really just h. So it's this limit as h goes to 0 of f of 3 plus h minus f of 3 all over h. So these are two really nice expressions for finding the slope of the line tangent to f at 3. Doug?
Why are you finding the limit of that whole thing? For instance, this limit is x goes to 3 of n minus f of x. Why are you finding the limit of x minus f of 3 over x minus 3?
Instead of just the limit of f of x?
As x goes to 3,
So the limit as x goes to 3 of f of x is really just finding this point, right? But I want to find the slope of the line tangent to this function at that point. So this thing right here is a special value. It's called the difference quotient. It's really the rise over the run. The change in the y values divided by the change in the x values. And this is the same thing. These are both called difference quotients, and they give slope values. Because you do the change in the y, the change in the function, the difference in the f values, divided by the difference in the x values. So when I evaluate the limit as x goes to 3, or as h goes to 0, then I'm really finding the slope of the line tangent to the curve at the point 3. And we're going to spend the next 3 weeks studying this concept. And then for 1 or 2 days we'll do something else. maybe we'll spend 2 weeks studying this concept, which is really like 1.5 quarters. All right? So this is a very important concept. Let's consider this function, y equals 1 over x minus 1. You should be able to graph this without a calculator. Can you? Do you know what the graph of 1 over x looks like? The precise way to describe it is it's a hyperbola with the asymptotes are the axes. You haven't seen very many hyperbolas that are turned diagonally like that, have you? Or you can think of it as a rational function with a horizontal asymptote, that's the x-axis, and a vertical asymptote, that's the y-axis, right? Then what does the minus 1 do? Shifts it to the right one. So we're talking about this curve is going to go through this point, 2, 1. It's going to go through 0, -1. Looks kind of like this. I want to focus on this point at x equals 2. I want to find the slope of the curve at that point. In other words, I want to find the slope of that tangent line. I want to find the slope of that tangent line. Let's use the limit to do this. At x equals 2, the slope of that curve, one way to do it is the limit as h goes to 0 of f of x plus h minus f of x over h. Oh wait, but we're not using x, we're going to use 2. So f of 2 plus h minus f of 2. What's this limit? Now, I notice a lot of students have trouble thinking about what f of 2 plus h is. But if y equals 1 over x minus 1, is f of x? If f of x equals 1 over x minus 1, what's f of 3? 1 over 2, which is 3 minus 1, right? What's f of 7? Yeah, 1 over 7 minus 1. What's f of -5? It's 1 over -5 minus 1. What's f of w? 1 over w minus 1. What's f of 2 plus h? 1 over what? Yeah. So this would be the limit as h goes to 0 of 1 over 2 plus h minus 1 minus 1 over 2 minus 1, all divided by h. I can see I didn't give myself enough room here. I'm going to continue this down here. If you need some more room on yours, I used to have some page extenders here, but they're in my other classroom. So 1 over 1 plus h minus 1 over h. What happens when I try to substitute 0 for h? What's the numerator equal to? 0. And what's the denominator? 0. I'm going to use a little trick here. Whenever I have a little fraction inside of a bigger fraction, I like to, what's my favorite pastime? Multiply by 1. So I'm going to multiply by 1 plus h over 1 plus h. I chose that because it's the little denominator. And when I multiply that whole numerator by this, the first term, the 1 plus h's, will cancel. So I just get 1 minus 1 plus h. And on bottom, I'm going to leave it in factored form. H times 1 plus h. So this is equal to the limit as h goes to 0. What do I get when I simplify this? What does the numerator become? Negative h, because this minus applies to both of these. The 1 minus the 1 is 0, and then there's a minus h. Any ideas what to do next? How? Yeah, cross out the h's. So I'm left with negative 1 over 1 plus h. When I crossed out the h's, I eliminated the 0 over 0 problem. It's those two h's that made it 0 over 0. But now they're gone. Now I can evaluate this expression by substituting 0 for h. Negative 1 over 1, which equals negative 1. Does it look like the slope on that curve is negative 1 then? Oh yeah, it does, huh? This tangent line has a slope of negative 1. So what's an equation for this tangent line? Yeah, that's true. But I like to use the slope, which is negative 1, and the point where it's tangent, which is 2 comma 1. And so I'll write the equation in point slope form. Y equals negative x minus 2 plus 1. This was really hard to find this limit. Don't you think? A little bit tricky? Yeah. Sorry. We've talked about a tangent line. A tangent line is a line that follows the curve, right? The normal line is a line perpendicular to that curve.
The circle is the same.
What's that?
The circle, they're always the same.
I still don't understand what you're saying.
In a circle, are the two lines always the same? And one on the tangent?
No.
Well, like, isn't, in order to be tangent to a circle, I thought you have to be to the radius.
The radius is normal to the tangent line. So the normal line and the tangent line are not the same. But the normal line and the radius are the same.
Oh, the normal line. Okay.
Yep, the radius is part of the normal line. In one of the greatest movies of all time, Raiders of the Lost Ark, the first Indiana Jones movie. Indiana Jones is fighting a guy on a tank. Do you remember that one? How many of you have seen Raiders of the Lost Ark? Okay. So he's fighting a guy on the tank. They're going down this dirt road, and Indy falls off the tank. But his suspenders get caught on this barrel that's pointed out the side of the tank. Remember that? And then they tried to ram him against the cliff. Anyway, the tangent line would be the line that would follow this cannon. If I stop here and fired my cannon, that's the tangent line. But if this was that tank instead, and it had the barrel going out the side, that barrel would fire along the normal line. All right? So this red line is the tangent line. This green line is the normal line. And they are perpendicular. So if you find the slope of the tangent line, what's the slope of the normal line? It's the opposite reciprocal. So if the slope of our tangent line is -1, what's the slope of our secant line? Our normal line. It's +1. It still goes through the same point, 2 comma 1. So the equation of the normal line is y equals positive x minus 2 plus 1. And there's our drawing. You with me so far? Remember that falling rock back in example 1 of the first day? I want to find the speed of the falling rock at time t equals 1. Now speed is the rate of change, right? It's the instantaneous rate of change. So if I remember right, that function was s of t equals equals 16t squared. So at time t equals 1, the speed will equal the limit as h goes to 0 of s of 1 plus h minus s of 1 divided by h. I'm using the limit of the difference quotient in order to find the rate of change, or the slope. What's that? Instantaneous rate of change is the same as the slope of the tangent line. So this is the limit as h goes to 0. What's s of 1 plus h?
The equation is like 16t squared.
Yeah. I wrote it there. Yeah.
16 plus 32 plus 16.
I think that's right. So how are you doing this?
Substituting in 1 plus h for 2.
Exactly. It's 16 times 1 plus h squared. That's s of 1 plus h. S of 1 is just 16 times 1 squared. And we're dividing by h. Oh, this one's going to be easier than that last one. The way I'm writing it here, where I write this limit as h goes to 0 each time, is something you should write when you're doing these kind of problems in your assignments. So 16, 1 plus h squared is 1 plus 2h plus h squared. Computer's a lot faster since I closed all those applications. Huh? It's not so bad. Those 16s cancel, so I have 32h plus 16h squared, all divided by h. Any ideas what to do next? Yeah, or I could just divide them by the h, right? What's 32h divided by h? So it's 32 plus what's 16h squared divided by h? 16h. Now before I did this, I couldn't evaluate this by substitution because when I put in 0 for h, I get 0 on the bottom. But now that I've divided by that, there's no more 0 on the bottom. There would have been a 0 on the top too. But I've taken care of that 0 divided by 0. And now I can evaluate this by substitution. I can substitute 0 for h. And when I put that in, what do I get? 32. What would the units be? Feet per second. That's the speed of the rock after 1 second. Using this limit to find that. It's far better than those physics equations, right? No. But it's because of this process that those physics equations came about. have these problems to complete. So it's almost 10 o'clock. I want you to take some time now to finish up assignment 2.2. Get any questions that you have on that answered by the people in your group. If your group can't answer the questions, then I can help you. And then we'll correct that toward the end of class today. No quiz today. So for your assignment today, you need to do 2.3 and 2.4. So hopefully you're finished with 2.2 and you can use this time now to start this assignment as well. Sorry. Good assignment. Get to work.